The force of gravity is an attractive force. That means that it pulls objects together. Any two objects with mass have a force of gravity between them. For instance, since both you and your desk have mass, there is a force of gravity pulling you towards your desk, and vice versa. However, this force is incredibly weak compared to the force of friction, which is why you and your desk don't accelerate towards each other and collide. The strength of the gravitational force depends on two factors. Number one is mass. If you increase the mass of one or both of the objects, the force of gravity between them will increase as well. For example, since the Earth is so massive, the force of gravity between you and the Earth causes you to constantly move towards it at a rate of 9.8 meters per second squared. If you were to compare that to the attraction that you feel from the force of gravity between you and your desk, you would be moving towards it at a rate of 5.25 times 10 to the negative 23 meters per second squared. To put this in context, if you were to start your car and move 1 meter at the same rate that you were attracted to the Earth, it would take you less than half a second to travel that 1 meter. On the other hand, if you were to do the same but with the acceleration between you and your desk, it would take you 3,170 years to travel that 1 meter. If one variable increases as you increase the other, we say they are proportional. Therefore, the force of gravity between two objects is proportional to their masses. 2. Distance. As you increase the distance between two objects, the force of gravity weakens. For example, on the surface of the Earth, your acceleration towards it is 9.8 meters per second squared. However, if you were twice as far away, you would only be attracted towards it at a rate of 2.5 meters per second squared. If decreasing one variable causes the other to increase, we say they are inversely proportional. Therefore, the force of gravity is inversely proportional to the distance between both objects. Now let's talk about orbits. In order for a planet to be in orbit, it needs to be in motion. If it's stationary, it'll just collide into a larger body. Here are some types of orbits: circular, elliptic, parabolic, and hyperbolic. The eccentricity of an orbit refers to how much its shape deviates from a perfect circle, or in other words, how squashed an orbit is.